Scientists aren't afraid of interstellar objects. Not anymore. After Oumuamua and Borisov, astronomers have accepted that debris from other star systems will occasionally drift through our cosmic neighborhood. But 3I Atlas is different. It isn't the size, or the speed, or even the fact that it came from interstellar space. It's the combination of anomalies, subtle, persistent, and stacking up fast, that has scientists more concerned than they are publicly admitting. Because for the first time, 3 separate mysteries are converging on a single object. An unexplained trajectory shift, a narrowband light emission that shouldn't exist, and now a pattern of behavior that suggests 3I Atlas may not be following the natural rules of small-body physics. The real reason scientists are concerned isn't sensational. It's scientific. The data doesn't add up, the models don't fit, and the universe is suddenly acting like it's hiding something. The first sign something was wrong came weeks ago, when multiple observatories noticed a tiny but consistent deviation in the object's path. At first, the shift was waved off, dusty images, imperfect tracking, atmospheric distortion. But the readings didn't go away. They stabilized. They repeated. They matched across different telescopes, in different countries, under different conditions. And more importantly, they formed a pattern. Trajectory anomalies aren't unheard of. Comets can drift when they outgas. Even asteroids can shift slightly due to solar radiation pressure. The problem is that 3I Atlas showed none of the usual indicators. No coma, no dust, no thermal spike, no jets, no spectroscopic signature of outgassing. Nothing. It was as if something invisible was pushing it. Not strongly, but steadily. That should have been enough to spark deeper investigation. But then the second anomaly arrived, and this one was even stranger. The James Webb Space Telescope pointed its infrared instruments at 3I Atlas and detected a narrowband signal, a clean, precise wavelength emission coming from an object that was supposed to be dark, cold, and inert. Natural objects don't emit narrowband light unless they contain specialized materials or are undergoing unusual processes. Yet JWST detected it twice. Same frequency. Same intensity, same region. Scientists checked the data for glitches, cosmic rays, processing artifacts. Nothing explained it. This single detection sent shockwaves through the astrophysics world. It wasn't bright, but it was sharp. Too sharp. And scientists hate precision where precision shouldn't exist. Then came the third concern, and this is the one that truly changed the tone behind the scenes. As researchers updated their models to fit the new trajectory data, something unsettling emerged. The deviation wasn't fading over time. It was growing, or at least holding steady. Natural explanations like impacts or venting lose strength quickly. The force weakens as the object stabilizes. But 3I Atlas wasn't stabilizing. The behavior looked more like a persistent external influence, tiny but continuous. This combination, a sustained push, a forbidden wavelength, and a lack of natural signatures, is what finally triggered the concern. Not panic, not wild theories, but concern rooted in the understanding that, right now, there's no natural model that explains everything at once. It's not that scientists think 3I Atlas is artificial. Most don't. What worries them is that they can't prove it isn't. And if they can't explain an interstellar object with physics, they have a problem much bigger than speculation. They have a scientific gap, something fundamental missing in our understanding of how matter behaves between the stars. Some researchers are quietly discussing the possibility that interstellar material is far more diverse than expected. Maybe some objects contain exotic compounds formed around ancient, dying stars. Maybe others are coated with materials not found in our solar system, capable of reflecting or re-emitting light in unusual ways. Maybe ultra-porous structures or metallic dust composites can behave like optical resonators. These theories aren't impossible, but no one has evidence yet. Others are exploring the role of magnetic fields. Interstellar objects passing through solar magnetic gradients could experience forces we haven't fully modeled. But again, nothing else passing through those regions behaves like 3I Atlas. And without a magnetic signature, the theory collapses. A few researchers have brought up the idea of unknown plasma interactions. Maybe the solar wind interacts differently with extremely low-density interstellar material. But this still doesn't explain the narrowband emission or the lack of a visible coma if sublimation were occurring. The truth is, scientists are running out of normal explanations. The concern grows deeper when you look at the pattern emerging between interstellar visitors. Of the 3 confirmed interstellar objects, Oumuamua, Borisov, and 3I Atlas, 2 have displayed anomalies that break known models. Borisov behaved like a normal comet, but Oumuamua's acceleration and non-reflective surface have never been fully explained. Now 3I Atlas appears to be repeating the same pattern of mystery, different details, same theme. The real fear isn't that 3I Atlas is artificial. It's that our understanding of interstellar physics may be flawed. If interstellar objects regularly behave in ways we don't expect, then our models of star system formation, cosmic chemistry, and deep space evolution might need rewriting. That's not catastrophic, but it's enormous. It means we've been blind to an entire category of cosmic phenomena. The concern is amplified by timing. 3I Atlas is fading fast. Soon it will be too dim for even JWST to observe. That means scientists have a narrow window, weeks, maybe months, to gather data before the object disappears forever. If they fail, the anomalies will remain unanswered, just like Oumuamua. 2 mysteries instead of 1. 2 data points with no resolution. 2 cosmic visitors behaving like they're following rules we haven't discovered. This is why scientists are suddenly serious. Not because of aliens, but because interstellar objects don't give second chances. We observe them once. They never come back. Behind closed doors, astronomy teams are scrambling to redirect instruments. They're organizing synchronized global observations. They're trying to secure telescope time on short notice, something notoriously difficult. They're debating whether to involve the public or keep discussions quiet until more data arrives. And they're arguing, fiercely, about what the anomalies mean. Some insist it's all noise, overinterpretation, confirmation bias. They say the trajectory shift will vanish with better measurements. They say the emission line is a thermal artifact. They say natural explanations will emerge. But others point out how similar the tone was during the Oumuamua debate. Back then, too, scientists insisted natural explanations would appear. They didn't. They offered hypotheses, but no one ever confirmed any of them. Eventually, the community simply got tired of arguing and moved on. But the data didn't go away. It just became an unresolved chapter in astronomy. No one wants 3I Atlas to become another unresolved chapter. The reason scientists are concerned now, truly concerned, is because the anomalies seem to reinforce each other. Each one alone could be dismissed. Together, they form a pattern that suggests something is fundamentally different about this object. Something we cannot explain using our current physics. Something that challenges what we think we know about interstellar matter. Some of the hypotheses now being privately discussed include ultra-thin layered materials, exotic crystalline structures formed in dying star ejecta, metallic composites unusual in natural bodies, unknown photonic processes, unclassified magnetic interactions, non-thermal emission mechanisms, or entirely new categories of interstellar debris. None of these require alien technology, but they all require science to expand. And yet, there is an unspoken concern, too. A taboo one. If a fragment of alien technology had drifted into our solar system, it would behave exactly like this. Not because it's active, but because technology is engineered. Engineered materials behave differently from rocks. They reflect differently, emit differently, move differently, and decay differently. No one is suggesting 3I Atlas is an active probe, but the idea that it might be technological debris, something ancient, something drifting for millions of years, has quietly resurfaced. Not as a conclusion, but as an unavoidable data point on the table. Because if nature cannot explain the anomalies, scientists must at least consider alternatives. The real reason scientists are concerned isn't dramatic. It's simple. 3I Atlas is behaving in ways that defy every category of small body physics they rely on to understand the cosmos.